All right, so for our design, this is where we left off in the previous lesson or the previous video. And this area here is where we're going to have to identify these groups as components that we could reuse in different or other programs or different projects if needs be. So that's another advantage of grouping items that you could potentially reuse in another project. So there is a technical term for this, and I believe it's CBSE, and let me see what that stands for. I believe it's component based software engineering. Now, why is this comes into play? Remember here, we're not doing object-oriented programming, so we need something else. We need to collect a bunch of related functions together in a group. And I mentioned that we're going to be needing some header files. Some will be customized, some will be standards. And that will pretty much be the components that we're going to need to write this program with. So what's going to happen is we're going to need our components right here, and they're going to be included within our application to put them all together as a product. Okay. Now this is here is the app. Let me be the app control. Okay. Component. And what's going to happen, this is going to give us the actual application as a product. And that's what we're aiming for. So we need these components right here. And the beauty about this approach is that you could reuse these components by rewriting another application control, and you could have a totally different application product. Or the same application product reversioned into a newer, much more improved version of the previous one. Okay? And again, this controlling here gets done in the controlling function, right? Where we're going to call main within a program. So separation, we're going to decouple all of these components because they could work on their own. However, there should be a high cohesion within the components for all the functions that exist there. And again, let me remind you, we're not doing OOP, but these concepts apply to object-oriented programming as well when we're dealing with classes and objects and what have you. At this time, we have a collection of functions. So what will be our different components that we're going to need for this program? Well, I mentioned CMath is one of them. Now, that's a header file for C++. And if you're doing a C program, that would be math.h, right? So math.h for a C program. C++, you could use CMath. Well, great. These are standard functions, or from the standard library, that will provide you with these functions. Sine, cosine, pow, what else? Square root. Okay? So you will have access to these. Now, what we wanted to do, however, is split the idea where we group this with add, subtract, multiply as our virtual package or our virtual component. So let's call it component 1. And sine and cosine will be under component 2. So this means that component 1 will be dependent on this component. Let's call it component 0, right? And so we're going to need that. For component 2, we're going to define the functions and how to use any of these functions, right? So these These are functions we're going to be using within our components. So this here will define the arithmetic calculator. And this here will define the trig calculator. Well, let's get started. So, and again, I'm going to make these as header files. Okay. All right. So to do this, let me go to my computer here for a second. Let me see if I can get my mouse back. Put this back. Okay. So let me just minimize this. And let's start from scratch. Okay. So we're under, so let me just get my keyboard. This out. Just bear with me for a second here. And I am going to do functions. And under functions, we're going to do a project calculator. Right? So instead this time of being called example 40, we're going to create a new file. And we're going to call it calc proj1. And we're going to save it under a directory here. So we're going to create a directory because this will be a project. So it will encompass various files. So it will have more than just one file, like the source code and the application itself, or the executable. So this would be my calc proj version 1. Okay? So that will be where I'm going to store my project. Okay? So for now, notice it's going to be empty. It's going to be under the directory functions for intro to programming. And the directory I want to save this, it will be under calc proj1. I'm going to go ahead, and you could use any IDE you want. NetBeans, I like Dev C++ on Windows here. It's fairly straightforward. It has the minimum bells and whistles without getting sidetracked with a lot of other functions and functionalities. So this is much easier to handle. Here they are. So now instead of saying new file, what I'm going to do is file, new project. So I'm going to create a project, and notice it's going to be, you're going to have to decide what kind of project is this going to be, all right? Is it going to be a Windows application where you're going to need buttons and all sorts of interfaces, right? Or you want a console. So for now, just a console would be fine. And I'm going to name it calc proj1 version 1. And I'm going to say OK, and it's going to say, where do you want to save this? So I'm going to go back to my desktop under, I believe, code testing, intro to programming, functions, calc proj1. And notice the name I want to kind of be similar to the directory where I save my file. Notice the extension now is a .dev, right? So, but it will generate for you a .cpp for the application where you will have main. So I'm going to say save, and notice it automatically creates, okay, a function main, and with my default settings on how I want this to work. So now notice it's called main.cpp. I don't want to save it as main.cpp, right? You can. However, I'm going to save it as calc proj1 or proj version 1. Same way, right? So, but the file now is a .cpp, so save. Right? So look at the ear here on the tab, calc proj1.cpp. Let's look at the directory now. Notice here I have a source code called proj or calc proj version 1. Same as the directory. We're good to go. So hang on a second here. Let me make sure I saved everything. Yep. All right. So again, under that directory, now notice I also have the .dev file. So what does this .dev file allow you to do? It allows you to reopen the whole project with all associated files all at once. Versus if you open Calc version 1, for example, you'll only get that file. Okay? Now, notice I only have a single file under that project. So if I clicked here or here, I am going to open Calc project version 1. That's it. But we're going to leave that, and I'm going to redo that little exercise when I close it and reopen it. Once I have a couple more files, so you can see by double-clicking on Calc project version 1, the .dev file, it will open everything for us at once, which makes life easier once you're ready to come back the next day to do some more coding. So what are the things we want to do here? So as you can see here, if I click the plus here on this one here, so just move a little bit things here. Notice an associated file with the project is your calc_proj version 1.cpp. Remember, I wanted several components. Let's include one of the components, which is component 0, right? We could do that right here. So include, and since it's from the standard library, CMath will work just fine. Oops, CMath, not SMath. CMath will be good right here. So in case we need to do anything here. Actually, since CMath will be used by the other components, we don't necessarily need to include it here. But I'm just going to leave it here as component 0. Okay? Let me save everything. Now, if I compile this right here, compile and run, you will see the press any key to continue, system pause is running, right? And let me just change the font size here. Make it a little bigger here, right? Excellent. Now, a little bit of details here. You're going to say, wait a minute. We've never seen this. Exit success. Exit success is just a representation for the value 0. Okay? We will have lessons on how to label things. So why? Maybe them specific flags will have specific names. What do you need to call, why do you need 0 here? We're going to call it exit success specifically for that one. 0 could be used somewhere else for other ideas, right? So to define this, and the keyword, we will be defining exit success as 0. It's already pre-done for us. So we don't need to do anything here in terms of predefining it. Now, if you want to put 0 here, semicolon, you're welcome to it. Nothing will change. Other few differences here. Notice now that main has some parameters. Don't panic. This was generated by the project, right? When I created the project, it did that for us. What it simply means is that you can run this application from a prompt and you can supply it arguments. So while you're running this program, it might need external data. Just like functions we've seen before, where it needed data from main, for example. It's not any different. So this way, programs can talk to each other, right? So this argument here is really, argument list here is really an interface to the outside world while you're at the prompt and you're ready to, let's say, enter calc_proj version 1.exe, the executable. And then you could supply it with the arguments that you want, which you could use them to customize how you want your application to run, if it has different default modes or any other versions that you may want to run. So this will give you a lot more flexibility. Again, we will get into these two in detail when we get into intermediate programming where there is a need for this. For now, it will not hurt to remove them or leave them alone. So just simply leave them alone. They were generated automatically, right, for you. Now, here, for some of you who haven't seen this syntax here, that's a pointer to an array, okay? And again, after we're done with functions, we're going to get into arrays, and then we're going to get into pointers, and then we're going to go back to functions and arrays with pointers to understand this notation asterisk. How does it come into play in C++, okay? A very important topic when we talk about pointers in C++. A lot of students, that's where they have problems with how memory is allocated, how it's managed, how it's used, how it's referenced, dereferenced. And again, keep that in mind. We will have a lesson on that. So I hope that gave you a quick tour as to what's expected here. Nothing major. This exit success is really the equivalent of 0. Don't worry about these arguments here for now, okay? So, excuse me. I need a couple, I need remember my design here, so let me just go back here. I need C02 and C01. And as I said before, I want these to be header files. Okay? All right, so we need to design these header files, custom header files, user-defined header files, okay, as part of this project, but as separate files. Each one will be in its own file. The advantage of having them in a separate file is that I could reuse them somewhere else, which leads us again, let me go back to the drawing, where we're using what we call CBSE format of design, or component-based software engineering. It applies nicely here when we're doing procedural kind of programming, okay? So let's go ahead and do that. Not that component-based is not done in OOP. It is. It's just a matter of how you group things, all right? You could have a group of object that represents some sort of an entity. So again, we'll get to that some other time. So now I could click here, new, as a file, right here, and it will ask me right here. So notice what I did here. So let me just cancel for now. And let me just close this. I didn't save it. And you could do that, or you could say file, new, source file. You could do this right here. And it will ask you again, do you want to add this to the current project? For our case, absolutely. It will be part of the current project. So notice what's going to happen right here under the project window. I'm going to say yes. And notice I have untitled to, right? And I'm going to name this file in particular, trig, or CO2 or CO1. I'm going to do CO1. Let's go back to my design. Stick to your guns. CO2. We're going to do CO2, which is, CO1, which is simply the arithmetic calculator. Let's do the arithmetic calculator, CO1. Now, this is where, in software engineering, we get into a point where, yes, we've gathered our data as far as from the user. How do they envision this program to work? One of the challenges for us as software engineers is, what do we start with? Right? How do you give value to CO1 or CO2 or C02 in terms of which one should you tackle first? That's where you may have to look at each one of these as what we call a story, and then assign some sort of a value, sometimes called value points. They could be priority, ranking, numbering, whatever you want to call it, depending on their level of difficulty or the time they take in terms of producing, okay? And the reason I'm going to give CO1 a lower value, when you give it a lower value, means it's easier to handle versus one that has a higher value in terms, if you want to use an integer to give weight to the level of difficulty. And we typically use Fibonacci's sequencing, where 1 will be a default, the easiest thing to do, 2 will be double the work, 3 will be triple the work, then you jump to 5, then 8, and then 13, and then you stop there. So 13 will be like your highest or the heaviest workload. When you have tons of things to do as a software engineer, you're going to have to organize, and it takes weeks to do things. You're going to have to organize things in what we call, if you're doing Agile and you're doing Scrum and Agile, into what we call sprints. And then within each sprint, you're going to break down the amount of work you're going to be doing within each sprint, where your velocity or the speed in which you accomplish any of these tasks is going to be as steady as possible. So things are predictable. Next, you're going to figure out, okay, well, what do I start with if everything is equal? Start with the most value, the most bang for the buck. So in our case, I want a calculator at least that will do addition, subtraction, power, square root, and that's easy, quick. I can do this versus this one. And even if their values, this one might include, because remember, I have some restrictions right here that says all my angles have to be in degrees, but we know that sine and cosine uses, from the CMath library, uses radians. So we're going to have to convert degrees to radians. So that's an extra step from a software engineering point of view, right? From a software developer point of view that we need to handle. Now, that's all transparent to the stakeholder in terms of who owns this project, in terms of ultimately who you're making this project for, right? Or building this project for, right? You want to abstract some of that difficulty. But in the meantime, you have to figure out, once you get into the details of how you're going to do this, obviously, you're going to have to figure out what level of difficulties you're going to encounter with each one of these steps, okay? All right, so let's get back to here. So I want to do CO1, which is a basic calculator to do addition, subtraction, power, and square root. And this here is going to be a header file, not a full application. So it will not have main in it. And we can quickly, what we call, prototype our application based on this particular CO. So that's the beauty here. That means I could be at least halfway functional during this sprint, during this period of time. And then the next sprint, I will do CO2. Right? So this 2 weeks, for example, allocated to do, so let's say I have 5 or 6 weeks to build this application. So you're going to break it up into 2 weeks runs or sprints. These 2 weeks, I'm going to do CO1. The next 2 weeks, I'm going to do CO2, etc. But if you're doing CO1, not only you're going to design it, but you're going to test it, and you're going to make sure that it's at least doing where it's supposed to. If you're missing, let's say you didn't finish up the square root, then you're going to have to move that to the next sprint when you're ready to do trig. You're going to have to reallocate time there, and so on. So let's not complicate this for now. Again, we're going to have a formal, eventually, lecture on software engineering. But I hope this has given you ideas what challenges you're encountering and how do you map some of these ideas you might hear in software engineering to right here, to coding. Coding should be the last thing on your mind, okay? But I've cut a lot of corners to match the two together for what we're doing here. Anyway, so let's get started with CO1, which is the basic arithmetic calculator. So I'm going to call this one arithmetic. Oops, let me just arithmetic.h. So that would be the file, how I'm going to save it as arithmetic.h, as a header file. So let's go ahead and do that. So I'm going to do arithmetic. And notice here where that says .cpp, don't do that. Click here and go to .h. So this is going to save it within the same project as a header file. Save. Notice now I have an arithmetic.h. Up to this stage, there is no relationship between calc version 1.cpp and arithmetic other than they're under the same directory project or project directory. There is no link. You're going to have to include it to make something happen. Just to show you, let's say this here simply prints cout, hi there. Right? And let's do something like this, and L. But for this to work, you need to have it in some sort of a function, right? So let's call this function here test1, and do a void test1. I'm going to change this just to show you what's going on, right? So, and that's all it does, right? So that's all there is in here. Remember, I told you that each one of these components will be a collection of functions. Right now, that's all there is in here in arithmetic, right? So it's simply similar to Hello World. So let me save that. So you could click the two disks here, or a single disk. This saves, if you click the two disks, saves on both sides here, both of these files, in case you make changes here and there. Remember, we're not linked yet, right? So if I run this program here, compile and run, nothing happens just other than press any key to continue. Now, what would be nice is that we can include now notice what I'm going to do. And since it's a user-defined header file, do not put the less than and greater than symbols. This time you're going to use quotes. And you're going to say arithmetic.h. Now you're going to link these two files together. There are a couple things you can do here. You could click Rebuild All right here, and that would try to link them for you. Now, if you type the wrong file, it's going to tell you there is a link issue. And notice here, I have a link issue. Let's see what the issue is. I called it arithmetic right here. Right? So let's see if the file is the same. So arithmetic, let me just, so it could be a misspelling, right? And it's saying it can't include that. Oh, I know why it doesn't. Now, it's not a problem with misspelling. It's because of the using namespace std is after we did this. Can we fix that? Yes. I can cut this right here and do that before you call the function. Now let's go ahead and compile this. There you have it. So that's how solve the problem. Can we instead say using namespace std also in the, so let me copy right here. That way you don't have to worry about it. So can we do it here? The answer is yes. This way, let me go back. Let me cut here. So the way you write your code is not going to change that much anymore. Yes, you're calling it again. We're going to learn about header guards in some other course. But notice now I'm no longer going to have that problem. So compile and rebuild all. And there you have it. Okay. Even though I've written it in two places, here it will handle this cout right in the namespace. Okay. Otherwise, you're going to have to do std 2:cout, etc., if you don't want this to be here. Right? And again, we're going to have another lesson on that. So, what was the point of doing all this? What just happened is we've linked these two files, but we're not using it yet. So if I compile and run this, nothing happens really, other than press any key to continue. Can I use it? Absolutely. What was the function name? Test1. Call it. Now you're going to say, well, wait a minute. You never defined test1 here. You don't have to, because it's defined in a linked file. Aha! As long as you're linked to this header file, you can actually use the functions within that file. Let's see if it works. Compile and run, and there you have it. Hi there. So that's going to have a major impact on code reuse as far as we're concerned. So strategically speaking, this is a good news in terms of code reuse. So you could write the arithmetic calculator totally separate and then use it in different versions of various applications that require an arithmetic calculator. So that arithmetic.h can be reused in other places where you simply write include arithmetic.h, and then you could use that calculator. At least that part of the calculator. Or that, that simply does arithmetic and doesn't do the trig. Remember, for this sprint, that's all we're doing. We're prototyping our arithmetic calculator. Is it going to be the final version for the arithmetic calculator? No. the design is very iterative. Now notice now I removed that function call. I don't need it anymore. That's because I don't need any of this stuff anymore. Now I'm going to actually build the calculator. So a couple things I'm going to need is maybe have a function that does addition for us. And then another function that does subtraction. So addition. Notice my documentation. Very important that you document what you're doing. Now, at this stage, I am documenting within my file. Eventually, you need to also write a separate documentation if you're doing this as a software engineer. And that would be good for troubleshooting, for you go on vacation, somebody else takes over your work, they know what you're doing. Subtraction function. So I am strategizing what I'm going to be doing. Multiplication. Function. Or job, if you want to call it. Division. Function. Square root. And then POW, or if you want from, this will be imported. Include, make sure you include CMath. C0, 0, right? So CO 0, right? Or what we had, that's what we called it in our design, or basically include CMath for this to work. Same thing here. If we're going to, so what is the function that we're going to be using? SQRT. So a lot of planning gets into coding before you actually write your first lines of code. And if you're going to use, also include CMath for this. Remember, CMath is going to be applying here. So if you're going to do that, why not include CMath while you're in here? Just in case in the application nobody included CMath. Remember, your code now is going to be transportable since you're going to do code reuse. What if somebody wrote an application, a .cpp file, didn't include CMath? Where at least you have included, just like using namespace, right? Remember we had a problem with cout? Well, same here. So make sure that you include CMath here, right? So that ensures that you're not going to run into a problem using any of these two functions, SQRT and POW, which were pre-canned and predefined already in the CMath library file. Fantastic. Now, let's think about what other things we want to do. During sprints, typically you're going to have meetings where you're going to have to decide with other developers what is it you're going to do, how you're going to do it, and when you're going to do it. And then you're going to group your work in tasks, right? A list of a backlog of things you want to do versus things you're actually doing versus things you've done. But to go from do to done, you got a lot of things going on. You got to test, at least at component level. And eventually you're going to be testing at integration level with other components. Right now, we're within the same component. We're going to be testing as we develop. This is almost like rapid development, as far as what we're doing right now. And again, this is an overview. It's a lot more detailed when we're doing real software engineering. So this here just give you an appreciation what's involved in a short amount of time, using a simple example like this one. So now this is where some decisions have to happen. In terms of, when an entity talks to another, remember I'm linking two files here, arithmetic and the calculator. Where do you want the work to be done? Obviously, the work needs to be done here under function. But who's providing the food to be consumed? And then where does the result go back to? Aha. This is where you're going to decide on the signature of these functions to be this way. Maybe I need to return a value. Call this addition. and then take two values, double n1, or if you want, num1, double, and num2. So what it's saying basically, let me open the curly brace and I'm going to define this function, is it's going to take two parameters, the two numbers that I want to add together, okay, and add them up. Okay, so great. So what are you going to do with this operation? This is going to simply return num1 plus num2. Remember, we had that option. You could have transitional variables like result, double result, and then result equal num1 plus num2, or you could simply return these two. Great. Now, so we could do this for the subtraction. We could do this for, and we could test it out real quick, right? So we could do double subtraction. Let's test it out. We're prototyping right now. And double num1, double num2. We're going to do the same thing. We're simply going to return the difference between num1 minus num2. Okay? We'll worry about the multiplication, division, and square root and power later. So let's prototype based on these two. So what could happen here? So let me just save this. By the way, if you go to execute and rebuild all, this will tell you if you have any issues. Or you can compile this particular file in itself to make sure that there are no issues, syntactically speaking. We haven't fleshed out all the logic yet. This here forces me to have a menu here for the calculator, maybe. Or maybe I should have a menu for this particular calculator. Ah, okay. Maybe it will have its own menu. And so this will have the arithmetic calc menu, its own menu. So the trig calculator would have its own menu. And then we could use that to choose what operation we picked. Do you agree? So in here, we could do something like we need int, and we're going to call this one menu if you want, or arithmetic menu. Be as descriptive as you can. So you want your function names, your variables, right, to describe what they do. If I could spell arithmetic. There you go. And what this would do, it will simply display a menu, right? So we could have a cout statement and return some sort of, so int choice maybe. And then we'll have cout. And so we're going to have /t/t, arithmetic calculator /n, maybe something like this, and then /t/t, /n. For now, we're just going to prototype it. So maybe this is print 1 for us, where we just need addition and subtraction, and then we'll show it to our client and say, is this what you want? Is this in line with your vision of what this application is going to be? Because you're going to need their feedback at the end of the sprint. And if they say yes, that's good, continue on, add the multiplication, then you continue with that. No, I didn't really like this. Can you rework the way the menu looks? Can you rework the whole application right now so it's not menu driven, but Windows based, right? I hope you have gotten that information prior to getting in here, because that's major work. So it's very important before you even get here that you've planned your work based on their requests and that you can meet their requests, and you know you can do that before you even got to where we are now. Otherwise, you're going to be redoing a lot of work. Okay? So anything you want to be doing after the sprint is really minor to move on to the next sprint. Lack of preparation and and planning is a killer, because it introduces a lot of logical and structural issues with your project. Flesh those out early before you get here. Okay, this would be subtraction, and then we're going to do, for now, /t/t. If we're done with this, are we going to control this? Just simply enter your choice for now. I'm not sure if I want to do, let me just, not a semicolon yet. And right next to it, don't do a /n. I want that CN. Actually, yes. So just put a semicolon here. Then I want the CN right there. That would be choice. It will blink right on that line. And then return choice. Now, this, remember, is a prototype. So if you want to make sure you have what we call data validation, error checkings, and so on, this is a good place to start. Usually with sprint 1, you just want to cram everything in here without going into a lot of details. Just get the project going and get the value in place. Get your client engaged, right? There will be bugs, I guarantee you that. But be aware of them and put a note right here that you're going to need some data validation at this stage when you come back and redo this part. This is just so you can get your client engaged. So how are you going to get your client engaged? Well, you're going to have to do something like this. Maybe you're going to have to display something. Do you want an arithmetic or trig calculator? So you need a menu here, maybe. Int menu. And let's define what's in it. Maybe something like this, int choice. And then maybe cout. And this will display calculator, or choose your calculator. And that would be right here. One would be the arithmetic calculator. And then /n here. And then 2 will be the trig calculator, even though we don't have it yet. So you're building the framework for your main application here as you're so maybe you have a team working on here, and then you have another team in parallel within sprint 1, right? Working on these two files separately, right? So notice you have two files. You could have two group people or two developers, each one working on the other. But make sure you communicate so you understand how to interface together. And you could be doing this using GitHub to version your progress as you move around. Now, if you're next to each other, it's great. But if you're online, and you need to talk to each other, Zoom meetings, GitHub definitely. There are other platforms you could use to coordinate work. Okay, and this will be so arithmetic calculator. What else? Trig calculator. And then here you're going to enter your choice. Or enter your calculator. Maybe here also Here you may want to terminate the program. So 3 is exit. And then here maybe enter your options. Remember, I'm writing this code on the fly a little bit, so your choice. And let's do this. Semicolon here, CN. Choice. No, so most of your coding should be very predictable by now. We've done an example prior to this project that's very similar to this, right? So return 0. This is where experience comes in. So you guys need to practice a lot of coding, right, on the basics. And then you start incorporating them in things like this in projects. So this will give me up return choice here, right there. So you're going to have to return that choice. So let me just compile everything or rebuild all just to make sure we don't have any issues. Everything looks good. Now, if what you need on your application here, you need to simply have a do-while loop maybe to at least call the main menu. Right? So maybe you need an int option and then a do while loop, do while option is not equal to 3. 3 is your exit, right? So what are you going to do? Well, you have two choices. First, you're going to call the menu. Let me just calculator. You're going to call the menu, right? So, or right here. So you're going to have to call the menu. So option equals, right? Menu. This here is going to drive your extended cases. Remember, let me go back here. Remember I had two cases, arithmetic and trig, right? It's gonna take you here. Okay? And remember, I need, for the include case, I need an input and output. Aha. So I definitely, for my include, so let me just go back here. I need double, num1, num2, result. So I can handle the what do you call it? My variables, input and output, because that's included within my application. Okay, so now, since my extended can be either optional or based on some sort of conditional statement, no biggie. If option equals 1, guess what you're going to be doing? Right? You're going to be running this program right here. Right? And maybe what you need now is some sort of a function to control how this application works. Your point of entry and how this application will work. Okay? So maybe you need something like this. And this will return a result. So double. This will return the result. Arithmetic operation. And it will take two numbers. Double, num1, num2. Or if you want, you could say n1, double, n2. Just you could name them whatever you want. They're totally separate from the num1, num2 that you have there in the other functions. Not a big deal. Here, you're going to call the menu that you want, and based on that menu, you're going to do a switch case based on the operations that you want. So, for example, for this one, you're going to call, so you need some sort of an int option here, equals arithmetic menu. Right? So let's see if it actually calls it. So the function we're going to need is going to be right here. Copy. we could do that. So I'm trying to decide if I want my input as part of the application or let the application decide on the input. So again, this is a design issue where I may have to forego this and just leave result here. Let the actual jobs decide what variable, because remember, if you're going to raise something to a certain power, right? Or if you're going to do an operation on a single number, right? Or something like that. It may take one parameter, two parameters. Let the application handle that from the back end. But I'm going to simply include the result. So my decision, this is a design decision. And I took my tablet out. Let me just use my mouse. I am just going to simply have the output as part of my include use case. And my inputs will be included with the extend cases. Okay, I can handle that. So that was a major design change. Okay, all right, so let me just go back here. And so I'm gonna pick up the result and manage the output here. So let's go back to the arithmetic operation. If that is a major design change, I am not going to need these guys here. I will declare variables based on what is it you're doing right here when I'm ready. So for example, switch based on the operation, which is option. And let me just close the switch case here. And we're going to do case 1. That means you picked addition. I'm going to ask for the user, so these will be local variables right here. Double. Remember, I want the application now on the back end. Num1, num2 here, in case I need that. And let's say result here. And remember, when I'm done, I'm going to return result, no matter what I do. I'm going to return back to main to be handled as an include use case. So here I might have something like this. Cout, enter num1 and num2. I'm going to do it all at once, right, for now. This is, again, a prototype. And then you're going to do cin, num1, num2, semicolon. And now we're going to call the addition operation right here, addition. However, we know that result is going to be equal to what the addition returns. And then supply it with num1 and num2. Put a break here. We're going to do the same thing for the subtraction. Case 2, cout, enter num1 and num2. We're going to subtract num2 from num1 for now. Later on, you can go back, sit down, figure out, okay, how am I going to word this better? What am I subtracting from? And again, that's when you're ready to do some of the refinement. Right now, I'm prototyping as quickly as I can, making sure that I have the framework that I need for this to work. Okay? Because the more things you accomplish up front, the easier it gets for you as you move forward. But make sure you start it on good footing, which means you understand the problem domain. Do not write code if you don't really understand what are the requirements, you didn't do a good requirement elicitation, right? So you will get confused and you will get into a conflict with the stakeholder or the product owner in terms of, as far as you're concerned. Subtract. You want to avoid that as much as possible. You want good cooperation, good communications. Oops, num2. And then I have the result, so break right here. And then, okay, so default, maybe if you want, cout invalid operation. Maybe something like that, /n. All right? So you could compile this, or you could simply rebuild all just to make sure you don't have any problems. So it's telling me I have a problem in here. So just double click where the function is. And it says addition undeclared. Okay, well, let's see if that is true indeed. And that is because I defined this function before addition. So the order is important here, right? So I'm just going to move all of this at the end, since the controlling is going to be done here. So just go at the end of this. So now it will see it. So let's go ahead and redo this. Rebuild all. And let's see here. Subtract undeclared. Did I spell it out something else? Subtraction. Indeed, subtract doesn't exist. So I have subtraction. Very nice. Read the errors. Okay? So let's compile this again, or rebuild all if you want. And notice now I have another error, which is fine. So what is it? It says expected. Yeah, I didn't finish my if statement here. Okay? Yeah, so I have a dangling if statement. Okay? So if in main I picked 1, which I want to call the arithmetic calculator, right? Then my result, my local result, is going to be equal to this function here, arithmetic operation, whatever this returns. So let's do that. Semicolon. So we did a function call for that case, right? So we're evaluating for case 1. Let's see how this works. So compile and run. And notice now I have a menu. Let's say I pick 2, nothing happens. Let's say I pick 3, well, that kicks me out. Great, let's run it again. This time I'm going to pick 1, arithmetic operation. Bingo, and it says arithmetic calculator. Do you want to do subtraction or addition? I want to do addition. And I want to do 2.3 space 6.1. Now, I haven't handled the result. I have a local result in main that I need to display. Right? So where can I display that? I can display that while I'm inside the do while loop, or the loop that controls the application, because I have the option of exiting after I've used either the arithmetic or the trig calculator. So for now, let's go ahead and exit. And since we did that, let's go ahead and print the result. Okay? So we could do that here after you're done with an operation. So cout the result of the operation is, you could do something like this, and then result. And so notice that the result got passed around as a return from these functions, subtraction or addition, whichever it is. And then when we're done, when we get out of arithmetic operations, we're back in main. So let's continue on with this. So we can do subtraction and addition. Let's test it out. So this could be the end of your 2-week work where you're ready, obviously in real work. This, as you can see here, I did this in less than half an hour. And that's with me talking. So this should take about 15 minutes to code all this. But in real world applications that take, if you're going to sit on a task should take you several hours. And if there are multiple tasks to make, to build some sort of a deliverable, that there are a collection of tasks for a deliverable, that will take a few days. Okay? Within your, and then if you have several deliverables that come together as your major components for your prototype, right? That should take the end of the sprint. By 2 weeks, you should have some sort of a demo to show. Okay. All right. So in our case, we have a demo that can do arithmetic operation, at least subtraction and addition. So let's try it out again. So compile and run again. All right. So here he is. So 1. We know the trig calculator is not there. So if you click on 2, nothing happens. Okay. Notice we get a fictitious result because we should have reset result to 0 so we don't get errors like this. So let me pick 3 here, just show you what you need to do. So during testing, maybe it's a good idea to set this to 0.0, it's a double, just in case you pick an operation where the result was not affected. So you're going to display 0.0. Let's do this again, compile and run, so you don't scare your customer. Okay, very important. All right, so they're not like, okay, I know you don't have the trig, but those large creepy numbers are not good to look at. So let's pick the trig again. Again, the operation is 0. That's more understandable. I don't have access to the trig calculator yet. We haven't designed that part, or that would be during the next sprint. Okay. For this sprint, we actually designed partially, at least, part of the arithmetic calculator. So let's go ahead and do that. And here's the arithmetic calculator. And we only met 2 requirements, addition and subtraction. We haven't met all the other requirements, which is what? Square root and POW, right? So we're going to have to go back, and you could see that it's easy to update to the next version now, knowing exactly where everything fits. So let's do a subtraction. Let's have a 2, space, and a 9. So we should get a -7. Looks good. It's working. 3, exit. Good. So I hope this was a good tour on what's involved and how do we convert from modeling to coding, while I expressed and talked about some workflows that are needed for these to happen. Okay, so initially all of this stuff is a bit confusing, but with time, as we do more projects together, you will get to marry the actual modeling, the actual coding, and the actual workflow together. So these 3 items together, if you can have a good handle on that, you're ready to be a software engineer. Okay? Eventually, you're going to have to add project management components as well. So that way, not only can you do some software engineering like Agile and Scrum under Agile or Kanban, but you can actually manage much bigger projects where when you're doing these processes, these software engineering processes like Agile, under framework of Kanban, or depending what you're doing, or Scrum, you're at ease with the whole flow of this iterative business of engineering and design.